Well, there was some technical hitch. Forget about it. I'm now getting back to that. I continue the discussion that what I just posted it a little while ago. Now, if you do it, that means what do you mean by this? Suppose in one particular case theta f is 60 degrees or mu is equal to tan theta of tan 60 root 3. And if I try to push this body at 30 or more, at 30 means exactly this, it cannot move. Now, if it cannot move, look at this. Suppose this is not possible, this is impossible. You are pushing this body down and you want it to go either way, it's impossible. So, it is impossible to move this body through pushing if the angle at which you push is greater than or equal to complementary angle to friction, angle of friction. If this is the case, no matter what force you apply, impossible to move the friction. Basically, pulling at an angle leads to reduced normal force. Reduced normal force leads to reduced frictional force, and reduced frictional force leads to reduced minimum force to move the body. That is why pulling is easy. Pulling in the direction of the interface makes no difference. Whether you push it or pull it, it makes no difference. But to do it at an angle, this is important. Why pushing is difficult, etc., never answer. Pushing need not be difficult. If it is pushing like this or pulling in this direction, it makes no difference. Both are one and the same. But if you take this angle, now that is going to be crucial. हेलो हाँ बोलिए बोलिए एक्चुअली मैंने लास्ट टाइम आया था तो मैंने एक राइट so no matter what force you apply through this pushing, it is impossible to move the body. We saw 3 cases so far. Okay, we will look at one by one of all those cases. So you have looked at in the horizontal direction. Now let us see the same horizontal direction. Suppose this is accelerating with here. We have already seen this before in the static frictional force. And this body is just about to slip relative to this surface. Always, as I said, take pseudo force. Pseudo force is m into acceleration of the system backwards, and therefore F. Why? The body is just about to slip. So if it is about to slip, this is mu n. It's a mu mg. So ma is equal to mu mg. This is the point. This is the point. I want you to be careful here. If you subject that lower body to an acceleration of mu g, then the body begins to slip. I am going to discuss a 2-body system separately. So I'm not going into the complications right away. First of all, I want to go to all those cases that I have worked out your static frictional, for which I try to work out your static frictional force cases. I'm now going to do those things first and then come back to the two body system later, because that requires a special attention from all of you. So the next one, if I see, yeah, I remember. This is, yeah, two cases I took, if you recall. I think I'll do both the cases here. One, two. This is subjected to alpha at t is equal to 0. This at t is equal to 0, it is subjected to omega naught. I have placed a body here, two different cases, a body there. This is r at a distance, subject to, it's just about to slip. Just about to slip. So I draw this FBD, mg is into the board, and because this is like this, actually this is how we are considering. I'm placing the body here, so mj down, n up, so mg is into the board, n is like this, and what provides the required centripetal force there? It should be a real force, and that since you said it is just about to, it is just about to slip. So I am taking FL, otherwise I could have taken FS, okay? Right. And what is this FL equated to? M R omega square. M R omega square. And what is FL? Union R mu mg is. N is not always equal to mg. I have shown in several instances. So be careful. What should be your omega naught? Or you may also look at what should be the linear speed, or omega naught. So it will be mu gr. Either way. So then just what is that angular velocity minimum for it to slip? That means already rotating and you are placing. That is why we are working on this. Here, I have placed it first and then I have put it to rotation with alpha. Let me say it will start slipping at t. At t, what will be the angular velocity? Omega is alpha t. And now, if you look, this is pseudo force MAT, which is MR alpha. Why? If I take a circle like this, tangential is, this is A. A is R, AT, tangential, R alpha. So pseudo force is like this. What is the pseudo force for centripetal? That is obviously centrifugal force, or MR alpha square is